start in 3 minutes. Today I will be solving Codeforces Global Round 1 as virtual participation. Chat, do we have chat here? We should. I will open it here and on the side. "40 seconds left. How often are there contests on Codeforces? Every few days. 20 seconds. Okay, let's start. I'm not very well prepared for that. I should have created more files, but that's fine. You're given n and with k digits, with base b. Determine whether n is even or odd. Base k, read them. An empty number would be even, so even is true by default. Now we read numbers from the most important one. For length k, read every next digit. If now if base is even, then only this digit is important. Otherwise, even XOR with this. Even, odd. Even, odd. Odd, even. Okay, let's submit that. It's on the right here. This was problem A from Global Round 1. Hello Lorenzo, hello Cezat. It's accepted. Nice. Problem B. M segment. Let's move the camera a little bit. M segments from 1 to M, each with 1 centimeter long. You want to cut tape and use them to cover all broken segments. You're allowed to cover non-broken segments. It is also possible that some pieces of tape will overlap. Time is money, so we want to cut at most k continuous pieces of tape to cover all the broken segments. What is the minimum total length of these pieces? So we have positions that we must cover here, and there is a number of them. Number of them k is here. And we must. Okay, let's binary search. If maybe I can copy this to Alt A, not to overwrite anything that I had. Now problem B, CPP. I'm going to binary search the answer. This is often what we do if we want to find the minimum value that satisfies something. Here I see how to check that if this is greater than the correct answer or not. So can we use this length of pieces or not? Print the minimum total length. Okay. No. Okay, so what about this? There are some places that we will cover. So there are some points that we must cover, and I will cover them with some pieces. What is important is the total distance from the first to the last piece minus these gaps that I don't cover, and I can choose k-1 gaps. Yep, that seems better. So differences, those gaps, maybe gaps is a better word, and I can choose at most k. If there are k pieces of tape, there will be k-1 gaps, and be of size m, not of size n. Read the input. If I is not 0, then put a gap between this value and the previous one. Sort the gaps. Answer is the total distance, so the last value minus the first value. And now let's say that this sorts decreasingly. So R begin and R begin, R end. So now we iterate with k-a. We take k-1 biggest elements of gaps. Answer minus equal gaps of I. It's not correct. Maybe I must increase by k. Here 6. I didn't copy. Yeah, I must decrease by k. I guess because those aren't points, these are segments. Maybe just plus k, but I'm not sure about that. Can n be equal to k? Yes, it can. Let's check what happens then. So the input, let's say, is 3, 3, 3, 1, 2, 3. It's 3? Yeah, I think it's okay. Let's submit that. Vlad, please talk English in chat. Problem C. Can the GCD and bitwise operations have anything in common? It is time to answer this question. We are solving right now problem C from Codeforces Global Round 1. Link should be in the description below the video. We should maximize given A, choose such B that the GCD of A XOR B and A and B is as large as possible. You're given Q integers, queries, each of them up to 2 to the 25. We want to maximize this. Okay, there is that. B was accepted. Awesome. There is that observation that A plus B is equal to, I think, A XOR B and A and B are related. What was the trick? A and B, these were the common bits, plus A XOR B, these are the different bits. I think if I multiply this by 2, then I get A plus B. Let's check that. If I add 1, 0, 1 and 0, 1, 1, if I add this I should get 5 and 3, 8, while AND would be 1, XOR would be 1, 1, 0, so a 6, and yeah, it's okay. So 2 times AND plus XOR is equal to the sum, and I think we should use it. So XOR is, this is A plus B minus 2 times AND. Maybe we'll use that. And then the problem becomes maximize GCD of XOR and A plus B minus. No. Maximize GCD of A and B, and from this we have that XOR is A plus B minus 2 times AND of A and B. We must maximize GCD of these two. Okay, so we can, for GCD of that will be the same as GCD of just this, because I can add or subtract one thing from the other. But I'm not sure what to do with that. I could iterate over A and B. These are like submasks of given A. If A is like that, if K is the number of ones, then there are 2 to the K possible values of this AND. Now how does A plus B look like? It will be, or we can even say A plus B minus 2 times minus AND. What can I do? What can I do? G will divide both AND and the sum. or AND and XOR, because this was given in the statement. Does it mean it must divide A? I don't think so. A and B will be some submask of this, like let's say here 1 and here 1, 0, 0, 0. This will be AND. Have you ever come across the formula conversion of XOR to AND, or was it an observation? I knew that fact. So what do we do here? Let's see in the standings whether this problem is easy and I should already solve it, or maybe it's hard. Yeah, it should be easy. People solved it in like 0 time. So I'm not seeing something. What about here? Maybe I can see some fact about it, or I can write a brute force and see what happens. So read the number of test cases, read, let's say it's n instead of a. Answer is 0 for b from 1 to n. Answer is maximum of itself, and GCD of what? AND and XOR. Yep. And XOR b and AND b. Can it be 0? Interesting. Let's see what happens here for now. Maybe this should be 0 and then it's optimal. 317, yeah, it's okay. And now let's change it to just printing values of first 100 numbers. Now I get argument, and I pass as an argument, and I can run it this way. Oh, so the answer is usually just power of 2 minus 1, except for 31, and then 15, 7, and so on. Okay, apparently. So let's make that faster. Can it be 1? No, it can't. I hope that this GCD works as expected for the second value being 0. I hope it's not undefined behavior. And now what we should do, if this is not a power of 2, if let's define PC as pop count, if PC of n plus 1 is not 1, then what do we do? we move to the next one. For 16 the answer is that. Answer is 1, while answer smaller equal n, answer times equal 2, print answer, return, print answer minus 1. I think this will work quickly, so in log of n. Now the only exception is this number, a number like 33. Was it 63 before that? Yes, it was. And for this number I can brute force, maybe. Or should I think more? What will happen here? A and B will be just, XOR B will be just the everything except for B, all the bits except for B. This sounds like just the greatest divisor in that case. So here for I is 2, I times I smaller equal n plus I, because for 63 the greatest divisor is 21. If n is divisible by I, print n divided by I, return, and here puts nothing. Let's see if nothing is ever printed. This will be square root complexity. 21. For 31 it's nothing. Here again nothing. What was the value here? Instead of nothing we should print 1, I guess. Yeah, so this will be 1. The last thing is that I don't want to have this complexity, or can I? 1000 times square root of that sounds fine. Let's submit. Otherwise I would just pre-compute that and remember the values. Hello Pratik. 19 minutes already passed. Wrong answer. Why? Oh, because I don't read from the input. Fortunately, wrong answer on the first test doesn't matter in the leaderboard. I won't get the time penalty. So people already solved E as well, not D. So I will move to problem E. I can also get that from this like list of problems. E has more acceptance. Okay, I have A, B, C already. Now we move to problem E. And magic stones, each with charge CI. Value CI will change to the sum of neighbors minus this value. From one sequence of numbers you want to get another sequence of numbers. Let's see how is it possible for the sample input. How to read test cases from file? You can redirect them. Just read about redirecting in your system. I use Linux. You can also use freeopen in C++ to read. We have 7, 2, 4, 12. And in what order? First we change this value to the sum of neighbors, which is 14, minus this value, it will be 10. And then we change this value. Sum of neighbors is 17, and minus 2 it's 15. Makes sense. Now, are numbers positive? They can be 0. Is it true that numbers will only get bigger and bigger? Not necessarily. A number can change to a negative number. If it is big, then this value can be negative. Maybe some people solve this problem because they already knew it. This looks like something that appears, might appear from time to time. Okay. The first and the last value don't change at all. They can never change. Let's see what happens. I have some, let's say A, B, C, D. If B, I change to C plus A minus B, and then change C. C will be this value minus C plus A plus minus B plus D minus C. So this will become, C will reduce, this will become A plus D minus B. Do I gain something from that? So C became this plus this minus this value. Maybe I should simulate the process in order starting from small values. Not sure. One moment. Okay, I'm back. Hello Rohit, I will answer your comment later because it's long. I don't want to read it now. And here the answer is obviously no, because the first and last value don't match. I don't have so far an idea for this problem. So now I might just, I have to think for a few minutes. The value C didn't disappear here completely. We still have C here. What about this? The sum of numbers in the sequence, oh, it can change. Maybe there is some total value that doesn't change at all, like the sum of differences of adjacent numbers. How will the sequence of differences change? If I have A, B, C, and D, and I change B, then what happens? Here the sequence of differences was B minus A, then what, C minus B, and D minus C. Now after I change B to A plus C minus B, the sequence of differences will be C minus B, then C minus that, which is B minus A, then D minus C. It looks like I just swapped these two differences. Maybe the sorted sequence of differences must be the same, because by making an operation like that, I swap to differences. Yeah, let's try it out. I'm copying my templates to ECPP and read n. I will create a function that will return sorted differences. Given n, create a vector of, let's say, a first. Read a of a. If I is not 0, differences push back ai minus ai minus 1. Sort. Return. And I must read one of them, second of them. If and puts a is b, then yes, puts prints a new line with something, and otherwise no. Let's check. I didn't close a bracket. Yes. And no. Is it everything that I need? What about this? Can n be n? Can n be 2? If n is 2, and I have 10, 15, and 11, 16, the answer should be no. But my answer is yes. So the sequence of differences isn't enough. The first character must match as well. I will here push back a of 0. So it would have to match as well. Let's submit. I think that was very easy to miss. List of problems. Next, I think I should solve D or F. I will read both and decide. Which one is shorter? Accept. Nice. How am I in standings? Half an hour passed. Marek Sokolowski wins for now. Everyone has ABCD for in standings. I'm not doing very well. N tiles in your hand. Each tile has an integer between 1 and m. You need to form triples. A triple is either 3 equal numbers or 3 consecutive numbers. Find the maximum number of triples you can form. That doesn't look very hard. But it can be, of course. For sure, we need to analyze it a little bit. I'm going to write down how many times each number occurs in the sequence, in the input. For the first sample, I see that number 2 occurs 1 time, number 3 3 times, number 4 3 times, then 5 2 times, 6 1 time, and 7 0 times, 1 0 times. I can either take 3 consecutive values and decrease each of them by 1, or I can decrease one thing by 3. Where is it bad to decrease something by 3? If because of that we won't use some neighboring values, and it is needed to form triples of consecutive numbers. When is it bad to use 3 consecutive values? Maybe if they should be used to form other triples, or should be used like that, with it, like I should take just 3 from some place. For example, here or this can be 6 and this can be 3. Then I should take triples like that. If I take this one, this will not longer be optimal. No, still it will be okay, because I will take this 3 with itself, this 3 with itself. So is there a case where it's bad to take 3 consecutive values? Maybe if I have 3, 3, 1, I can take this triple, and the answer would be 2. And if I don't do that, and if my first move is taking 3 consecutive values, the answer would be 1. I'm just thinking about some greedy approach, and I don't see it. Do you recommend solving problems from looking for a challenge? Yes, but only if you are already experienced, because that book contains quite hard problems. Okay, I think the quality of this book is very nice. Again, I don't know yet how to solve a problem. Can I have some dynamic programming? What happens after I decide everything about some prefix? I want to know how many, maybe a new drawing. After I decide about some prefix, I want to know how many triples like that and like that I chose. If some number is very big, like much greater than neighboring values, I can for sure use some triples of this value. If I have 2, 10, 2, and whatever, then I can decrease this to 7 at least, or even to 5. Because this value will not be in more than 4 consecutive triples like that. But this is not enough. Let's read problem F, maybe it's easier. Eulerian traversal of a tree. You have some function. You have to answer Q queries. This looks like a lot of implementation. So I would prefer D. 40 minutes passed. How much? Yeah, almost 40 minutes. By the way, here it should be 4, not 5. Either greedy or dynamic programming. But dynamic programming would be, I think, n-cubic. I have to move with prefix, then I must know the number of times I use the next value and the second next value in these two types of consecutive triples, and that would be n-cubic. Will analyzing samples give me anything? I don't think so. Do you know how to solve this? Oh, so it's not it's not my format. I would prefer to know how many times each number occurs. I'm almost sure that. One moment. In my sequence, the sum of numbers, the sum of occurrences, sum of AI, my occurrences of everything, maybe not AI, count of I, is equal to n. And that can be helpful. These numbers can't be all big. And the length is m. So maybe dynamic programming makes some sense. Because we can't take something too many times. Maybe we should first decide about like one value. If something is divisible by 3, if everything is divisible by 3, we can just take the triples as a whole. I mean, if my sequence is 6, 3, 3, 9, then I will take everything efficiently. I will use all the numbers. The case is different if something is not divisible by 4. We can combine multiple things to maybe use those values modulo 3 more efficiently. In particular, if 3 consecutive values are not divisible by 3, let's take a triple of consecutive numbers to, for example, change 4, 5, 4, 3 to 3, 4, 3, 3. By taking these 3 consecutive values, and then here taking triples as a whole, I will get 12 from of 13, which is as efficient as I can be. What if values not divisible by 3 are distant from each other, like here? Can I use them together in some way? What is the answer here, by the way? It's 3. So I can take 3 triples, what means among these 10 numbers in total, because the sum of those is 10, n is 10, The answer is 3, which means I will use 9 of 10 numbers or tiles in the story. By the way, if you're joining now, I'm solving problem D from Codeforces Global Round 1 in virtual participation. One, 3, 3, 2, 1. I can take this triple. Then it is 1, 3, 2, 1, 0. I'm taking this triple and this triple. If among 3 consecutive values the sum of those values modulo 3 is at least 2, then maybe it's good to take them as 3 consecutive values. I mean, here, if we don't take 3 consecutive values here, these 2 numbers will be wasted. But for this case, 3, 2, 2, no, this is not a good example. 3, 2, 2, 2, yeah, here I shouldn't take this triple, even though it looks like otherwise something will be wasted. I should prioritize this triple. If there are 3 consecutive values where none of them is divisible by 3, then I can take these 3. That's some start. Can I suggest something? Regarding to the solution of a problem, not really. I would prefer to do it myself. Sometimes I have streams where I just solve problems, then you're free to suggest something. Maybe I will do such a thing after I'm done with this competition, this contest. Okay, what if there are no 3 consecutive values that are not divisible by 3? There can be still 2 of them. And there can be situation 1, 3, 3, 2. I should still use triples like that. But maybe I can use any of them if there are no 3 consecutive non-divisible values. By the way, changing this to 2 to 1 will make those 3 values non-divisible by 3, so we will automatically repeat the operation. And is it bad? It can be, I guess. I need a new canvas. What if I have 3, 3, 2, 2, 3? Should I do it like that? Hold triple, hold triple. I guess so. But does it hurt me in any way? Can I always say then if there are no consecutive 3 non-divisible by 3 numbers, even if 3 consecutive numbers are not divisible by 3, I'm not sure that I should take them. Maybe since it's just problem D, not something harder, I should guess that this greedish approach will be enough. So I want to simulate a greedy approach where I take first of all a triple of consecutive numbers that are non-divisible by 3. If such a triple doesn't exist, then I try to take triple of consecutive numbers non-divisible by 3 except for one of them. And what happens finally if one number is divisible by 3? Yeah, like situation 1, 3, 1. It's still okay to take this. Is there any difference? Okay, what about this part? Is it any difference between taking this triple and this triple? If something more is on the right. Can we find looking for a change book online? I don't think so. I hope that my approach works at least for samples. Let's try something. Maybe it will be quadratic for a moment. I just want to see whether it works at least for the sample tests. I'm reading the input. Every next value say x, and I say plus plus count of x. The vector count must be able to store values up to m, so the size will be m plus 1, and here I define n as don't use n. This is like a hacky thing, so that I wouldn't use n by mistake. Answer is 0. Okay, but what about this case? If there is 3, 3, 1, I shouldn't take this. But if it's 3, 3, 2, it doesn't matter, because I will anyway get 2 triples. So the question is, in this case, should I take 3 consecutive values or not? While true, anything happened is false by default. If not anything happened, break, print answer. Here I will do some greedy part. For everything remaining in count, answer plus equal x divided by 3 with floor. And what happens here? I iterate over everything up to m minus 2 and count good numbers will be count non-divisible by 3 numbers. For j in I plus 1, I plus 2, if count of j, I will multiple times use this. So let's create a vector of indices for I plus 1, I plus 2. for j in indices, if count of j modulo 3 is not 0, then plus plus count good. If count good is equal 3, then anything take is false. I will change take to true, and at the end if take, then iterate through indices, increase count of j, increase the answer by 1, and say that anything happened is true. Even more, I will say break or not. I should first of all iterate the whole array and check whether some 3 consecutive values are not divisible by 3. Only then, if nothing happened, then try 2 consecutive values. Yeah, I think that would be better. So, like, turn from 1 to, I don't know, 3. Our requirement. First, 3 consecutive non-divisible by 3, 2 non-divisible